Hi, welcome back to my channel Maths with Armin. This is another video on factoring cubic expressions of the type ax cubed plus bx squared plus cx plus d. In this video, I want to show you the approach to be used if only one rational factor is possible. Right? Please, if you have not subscribed to my channel Maths with Armin, please subscribe. I hope you will find this video useful. So let's start. In this video, I'm going to show you how to find the quadratic factor if one rational factor is known of the cubic expression ax cubed plus bx squared plus cx plus d, and we're not going to use a calculator. If we have a cubic expression ax cubed plus bx squared plus cx plus d, and only one rational factor is available, right? Or one rational factor is possible for this. Then it can be expressed as a linear times a quadratic. Because a linear is a first degree, and a quadratic is a second degree, and a first degree times a second degree gives you a cubic, right? Now we are going to have two options. We're going to look at the case where one of the linear has a positive factor, and then it will go with a quadratic, or we're going to look at the case where sometimes the linear factor has got the linear factor has a negative value in there. So we're going to look at these two options here. Also from this we can see that this a value times the c value, their product should be equal to this d value, right? So a times c must be equal to the d. And these are the and in the examples we're going to look at the case where you once have a positive and sometimes you have a negative. Now let's just look at the cubic expression. So if we're going to write the cubic expression there and the linear factor is known, then we'll have to get a quadratic factor there. Now there are two methods I'm to explain in this video. The one video is where we're going to do it by inspection, and the other video is here where we're going to use the sum or the difference between two cubes. Now let us first look at the method of finding the quadratic factor by using inspection. I'll explain to you what I mean by using inspection. So for the first example here, I'm taking a cubic expression, and in this cubic expression here, the constant value is positive. As you can see, my constant is a +1, and I'm also taking my coefficient of x cubed to be a 1. So in other words, I'm taking a 1x cubed. I'm taking a very basic example first with a 1x cubed, and I'm taking a positive just for you to see the method first. And I've got a positive factor as well. So I've got my factor x plus 1. Now I'm just writing that's x squared. I don't have to write down the 1, but I've just inserted the 1 there because we're going to look at this one. I want that to be standing out. Now, if I have a cubic, I can express it as a linear times a quadratic. So a linear times a quadratic will give me a cubic. So they give me the linear. So I want to find the quadratic. To show you how to do that. So that is what my answer should look like. A linear times a quadratic. Now, what do we want to find first? You see in the quadratic, there's a term in x squared. There's a term in terms of x, and there's a constant value. So we're going to look for the term, the first term, in other words, the term in x squared first. So I want to find this missing value here. Now to find that missing value, I need to look at my x cubed. So in other words, x cubed will be x times what? I have an x, so x times what will give me an x cubed. And what will that be? That's right, it's x squared. So in other words, my first term in my quadratic is going to be x squared. Now next, I want to find so my first term there is to find my first term of the quadratic. Now for the second step, I'm going to find the constant term. Can you see there? There's a constant. I want to find that constant term. And to do that, I need to use the constant term of the cubic. So that's 1. So 1 times what 1 times what will be 1? In this case, 1 times, that's right, it's a 1. So in other words, my second step, I get my constant term. There I can insert my constant term, which is plus 1. Now what remains now is I want to find my middle term, right? So that's my step 3. I want to find this term here in the middle. And to do this, I'm going to need this 1x squared. You see there's the 1x squared. So we write down 1x squared. But 1x squared with something. 1x squared with something should give me this term here. See, that's why I highlighted it there. So I need that 1x squared there. Now 1 plus what is 1? 1 plus 0 is 1. So in other words, this missing is actually a 0x there, which is the same as 0. So I need to insert a 0x. Can you see there? That gives me 0x. It's not wrong to write that, but we can write it in a much simpler way. And we can write it as, so step 3, I had to find my middle term. There's an x squared plus x. In this case, the middle term was 0. Let's just check whether this is correct. If I take my given expression and I only look at the coefficients, that's 1, 1, 1, and 1, and I add up those coefficients, I get a 4. If I look at my factors and I just look at the coefficients, it's 1 plus 1 and 1 plus 1, which is 2 times 2, which is also 4. So there I factorize that. Now let's just look at that quadratic that we calculated. If we work out the discriminant delta, which is b squared minus 4ac, you can see the b value is a 0. So I put in the 0 there. My a value is a 1 and my c value is a 1. So in other words, there I end up with a negative 4. And negative 4, if my discriminant is a negative 4 or my delta is a negative 4, I know I'm going to get non-real roots. Let's consider another example. Again, we're going to take our constant value positive number and we're going to take our a value of 1 again. So let's look at an example I've chosen. So I've got a 1x cubed and you can see my constant is positive. I first want to do this so you can get used to the method, but we don't have too much trouble with negatives and positives. So I'll take my constant positive and I also got the x plus 2 as a factor. Let's see whether we can do that again. So if this is my expression, and again I want that 1 just to stand out there. So I'm going to have a x plus 2 times my quadratic. So I'll have a linear times a quadratic. So there's my expression there. So you can see this is the given factor, x plus 2. I want to find the quadratic factor. Recall what we do for our step 1. We first have to find the term in x squared. We first want to find this term. In other words, x times what must give me x3. I can see x3 is the same as x times what should go there. That's right, it's x squared. So my first term of my quadratic is just x squared. Right? So that's my first step to find my first term of my quadratic. For my second step, I'm going to find, what we're going to find? That's right, we're going to find our constant value. So the constant value there is 2. 2 times what value will have to give me? And what am I going to need here? I need that 6. So 6 I can see is 2 times what? And 2 times what is 6? That's right, 2 times 3. So it's a positive 3. So my constant value is a positive 3. I don't just write down 3. I don't write down the sign with it, positive 3. So my second step, I find my constant value. Now next we're going to find the middle term. That's my step 3. Okay. And how do we find the step 3? That's right, I'm going to look at the x squares. And you can see there's a 2x squared. And so that 2x squared with something must give me what? Let's look at the other x squared. There's another x squared. Must be equal to 1x squared. So 2 plus what will give me 1? That's correct, a negative 1x squared, or just negative x squared. So in other words, I need a negative 1, right? So I'm going to put in that negative 1, but I only put the x down. So it's negative 1. x, because x times x squared, you see, x times x will give me a x squared. X, I can't put a square here. So there's already a square, the middle term must only be a x. X times negative 1x will give me my negative 1x squared. And there we have actually factorized that. We can't simplify. So my third step is to find my middle term, looking at the x squares only. There's my factorized cubic expression, my linear with my quadratic. Let's check that again. How do we do that? 1 plus 1 plus 1 plus 6, and that gives me 9. Then I use here 1 plus 2 times 1 minus 1 plus 3, and that gives me 1 plus 2 is 3. 3 times 3 is going to be 9. Let's just work out my discriminant again. You can see my b value here is negative 1. My a value is a 1 and my c value is a 3. And if I simplify that, I get a negative 11, and negative 11 gives me none. So this quadratic here has non-real roots. Therefore, x plus 2 is the only rational root that I have here, right? Now let's look at the third example. In this third example, I'm still going to have my leading coefficient being 1. In other words, that's going to be a 1. But I'm taking a negative d value, a negative constant. You can see I've got a negative 6 there, and I have also choosing a negative factor here. So there's my expression. What do I want to get? I've got the given linear. I have to find the quadratic, right? In other words, I need to find this quadratic. See, the x minus 3 is given. I want to find the quadratic, and I'm just doing that by just inspecting what I've got there. So x with what gives me x3? That's right, x with x squared. So my first term of my quadratic is x squared. Then what do we have to find next? So the second step, we have to find our constant term. So negative 3 with what will give me? That's right, will give me a negative 6. So negative 6 is negative 3 times, that's right, times a plus 2. So my constant term there is plus 2. You can check. Negative times a positive is a negative. 3 times 2 is 6. So that's my second term, finding my constant. And to find the third one, I want to find my middle term. But to work out the middle term, I need to look at, that's correct, the term in x squared. That gives me negative 3x squared. And this negative 3x squared with something must give me a, there's the other term in x squared, negative 2x squared. Now negative 3 plus what is negative 2? Negative 3 plus 1. So I've got a 1x squared there, right? But I write down 1x. Why not squared? Because x times x will give me the, see, there's the term in x squared, there's another term in x squared. So a negative 3 plus a 1 will give me the negative 2 that I want. But I don't have to write down the 1. I can write it down just as x squared plus x plus 2. Let's just check that again. If I look at my coefficients, it's 1 minus 2 minus 1 minus 6, which is negative 8. I look at my coefficients here. 1 minus 3, 1 plus 1 plus 2, which is negative 8. Let's just check my value for my discriminant. My b value is 1, my a is a 1, and my c is a 2. And if I substitute, I get a negative 7, which indicates to me that this quadratic has got non-real roots. So the only real or rational root here is the x minus. There I found my quadratic. Now let us consider one more example. And in this example here, I have a negative value for d. The constant is negative, and I've got a negative factor. But as you can see here, the a value is not 1, right? The leading coefficient is not 1. I've got a 2x cubed here, okay? So there I've got my equation, 2x cubed minus 3x squared minus x minus 12. As before, we know it will consist of the given linear factor times a quadratic factor, right? So we have to see what do we need to get there. So that is x minus 4, and I'm going to get, let's get my first term. So my first term there needs to be, let's see what we need to get here. Here we need to get 2x cubed. So if I want 2x cubed, x with what will give me 2x cubed? That's right, 2x squared. So here the first term of the quadratic is 2x squared. Okay, so that's our first step, finding the first term of the quadratic. Then next here we need to get the constant term. Step 2. So what is my constant term? My constant term is negative 12. So negative 12 is equal to negative 4 times what? That's right, it's equal to positive 3. So my constant term there would be positive 3. Okay. Now the second term was the constant term there. Now for the third term, we want to find the middle term there. So the third step, we want to find the middle term. So I need to use my term in x squared, and here it is negative 4 times 2, which is equal to negative 8x squared. But negative 8x squared should give me a negative 7x squared. So what should I do with negative 8 to make it a negative 7? That's right, I need to add a 1 to it. If I add a 1x squared to it, I get negative 7. So my middle term there will be 1x, and as before, we know we don't put the square down because x times x will become the square. So there I factorized. I've got the given linear factor, which is x minus 4, and I now need to multiply it with 2x squared plus x plus 3, which is my quadratic. Right? Let's check the discriminant value. My a value, you see, is 1. My b value is a 1. My a is a 2, and my c is a 3. And if we count again, we see that this quadratic here has non-real roots. So the only real or the only rational factor would be the x minus 4. We can verify that, and we can see there 2 minus 7 minus 1 subtract 12 gives me negative 18. And if I look at my factors, 1 subtract 4 times 2 plus 1 plus 3, that is 6 times negative 3 is also negative 18. Okay, so it doesn't matter whether I have my leading factor a 1 or not, the method is exactly the same. Right? Just here, you can see in this term here, I don't have an x squared. Because of a 2, I've got 2x squared. It was a 3, I would add 3x squared. Now, let me just show you how you can get that quadratic just in one line. There's an example, 3x cubed plus 8x squared minus x plus 6 with x plus 3 as a factor. Let's just write down the expression. I'm just color coding it so you can see there I've got a 3 and an 8 and a 6. So they are giving me x plus 3 is a factor. So I write down the factor. Now I put down an empty bracket there because I'm going to put the quadratic in. So if I want x with what gives me 3x cubed? That's a 3x squared. Then 3 with what will give me a 6? That will be my plus 2. I've got a 9x here. You see there's a 9, and I've got an 8. What must I do with 9 to make it an 8? Right? You just subtract 1. So I subtract, and there I found my quadratic expression. Let's just check whether that is in fact correct. I've got 3 plus 8 minus 1 plus 6, which is 16. And if I take 1 plus 3 and 3 minus 1 plus 2, also gives me 16. So you can see you can do all of this in one term, one line. Now I want to show you another method of finding the quadratic factor, and this is by using factors of the sum of cubes or the difference of cubes. I'm to use this, just another method. I'm going to take the same examples from the previous one to show you that you can also use this method. I'm going to show you the method. Let's just briefly make sure we understand how to factorize the sum of cubes or the difference of cubes. Let's take the sum of cubes there. I've got x cubed plus y cubed. It consists of a linear factor and a quadratic factor. Right? So x cubed plus y cubed becomes just x plus y. Then to get the first term here for the quadratic, x with x squared gives me x3. Y with y squared. And this will always be a positive, because a positive times a positive has to be a positive. If I have a positive here, I must have a positive. Now the middle term, if there's a positive here, the middle term will be negative. And then I just multiply x times y, so that just becomes xy. Let's take an example. I've got a cubed plus 8. So I'm going to have my linear factor and my quadratic factor. A cubed will be a, and the cube root of 8 is 2, so that will be a plus 2. Then a with what gives me a 3? A squared. 2 with what gives me 8 will be 4. It's always a plus 4. Then if there's a positive, I need to have a negative. But then I'm going to have 2a, so it will be negative 2a. Let's take the difference of cubes, just a slight modification. There I've got a cube minus a cube. So I'm going to get my linear factor and my quadratic factor. So x cubed minus y cubed, my linear factor would just be x minus y. If I have an x here, I need to have a x squared there. If I have a y there, I need to have a y squared there. But remember we said that's always positive, because a negative times a positive will give me back my negative. Now, if there's a negative here, I need to have a positive there. And then I just have my term xy, that's my middle term xy. Okay, let's take an example. I've got b cubed minus 27. So I'm going to have my linear factor and my quadratic factor. B cubed will be b, and cube root of 27 is 3. So that's b minus 3. If I have a b there, I need to have b squared there. Negative 3 times positive 9. See again there, that's a positive. Now if I have a negative here, I need to have a positive middle term. That will be positive, and 3 times b will be 3. Right? So we're going to need this here. You need to know how to factorize a sum of cubes or a difference of cubes. Now let's look at our first example. You can see in this example here, I've got a positive constant. I've got a positive constant, and I'm taking one where the a is 1. Just a simple example here. It's actually the same example I used in the previous method. Okay, so we've got the cubic polynomial, and we've got one factor. X plus 1 is a factor of that. So let's start. There's our cubic polynomial. So the first thing I'm going to do is I'm just going to move that. Okay, so in other words, that x cube, I'm just leaving a little space. I've just put the quadratic part. See, there's a cubic part and there's a quadratic part, the x cube plus x plus 1. So I'm just, because I want to add something here. Now what do I add here? I look at the factor that's given. I've got a plus 1. So I'm going to add plus 1 cube here. So what I'm going to do first, I add plus 1 cubed. Right? That one is the one of the factor that's given. But if I do that, if I add plus 1 cube, I'm changing my expression. How can I balance it out? So if I add there, I'm going to subtract the same amount, right? So whatever I add, I subtract, so I'm not changing the value of my cubic polynomial there. Now, so now I've got a cubic part. You see, there's the cubic part, x cubed plus 1 cube, and I've got a quadratic part. See, there's the x squared, there's the x, and plus 1 subtract 1, the constant is now gone. So I've got my cubic part and I've got my quadratic part. Now let's factorize the cubic. The cubic, as we did in our previous slide, is x plus 1, x squared minus x. If there's a positive, there's a negative. It's always a plus there. And the quadratic, this quadratic here, because it consists of two terms, quite simple, I can just take out the common factor. Now what do we notice? One of the factors of my cubic matches with one of the factors of the quadratic. So I can factorize that further. I can take out a common factor of x plus 1. So if I take out a common factor of x plus 1, I'm left with x squared minus x plus 1 plus that x. And if I simplify that, you can see there's a minus x and I add a x, so they cancel out. So my answer is just x squared plus 1. Let's just look at that quadratic. The b value is 0, so if I use my determinant, I get 0 squared. My a and my c value are both 1, so 0 subtract 4 gives me negative 4. And because my delta is negative 4, my discriminant is negative 4, the quadratic there has non-real. So I've got my given linear, and my quadratic here in this case has non-real roots. Let's just verify that. If I take my original expression, I just take the coefficients. So that's going to be 1 plus 1 plus 1 plus 1, which is 4. And I take my factors, which is 1 plus 1 times 1 plus 1, which is also 4. After this, we're going to take another example where we don't have positives all over. Another example, again, I'm taking positives here again. But I just have a different factor, x plus 2. So let's say there's my cubic, x cubed plus x squared plus x, and I got a plus 6. First of all, let's separate the cubic from the rest. There's this cubic there. Now, because they give me a factor x plus 2, I'm going to add to this plus 2 cube. But if I add plus 2 cube, I need to balance it out. So I will subtract 2 cube. Okay? And if we simplify that, we now notice that we're going to have x cubed plus 2 cubed. There's the cube parts. And then I take the quadratic part. There's x squared. There's x. 6 subtract 8 is a negative 2. Okay? So now I want to take there's a cubic. I separated the cubics from the quadratic part of the polynomial. So I factorize my cubic. If there's a plus 2, that's going to become a negative, right? And 2 times 4 is 8. Then the quadratic there, that's a very simple trinomial. I can factorize it as x plus 2. And then the other factor there is x minus 1. Now we notice the x plus 2 is common to the cubic and is common to the quadratic. So I can take out the x plus 2 as a common factor. Take it out as a common factor. I end up with x squared minus 2x plus 4 plus x minus 1. There are some like terms. I simplify the like terms. Negative 2 and x is negative x. 4 subtract 1 is 3. Okay. Let's just check the value of the discriminant. My b value is negative 1 and my a is 1 and my c is 3. If I substitute it into the formula for the discriminant, I end up with negative 11, which indicates I get non-real roots. So this is the rational part, and this is the non-real. This one has got non-real. I'm going to get, if I solve, I'll get non-real roots. This is the non-real part. Let's check the value. So there I would have 1 plus 6, which gives me a 9. And my factors there are 1 plus 2 and 1 subtract 1 plus 3, which also gives me 9. Let's take an example, and we're going to take some negative values. You can see there I'm making my constant a negative, and I'm also going to choose a negative factor. I've got some negatives there, and I've got a factor with a negative constant. So let's take my expression. So the first thing I need to do is I need to just separate them, right? So I've got the cubic part, and I just take the rest of the terms and I have there. Now, because I've got minus 3, I'm going to subtract 3 cube. Okay, but if I subtract 3 cube, I need to balance it out, so I'm going to add 3 cube. Okay, and now I'm just going to just group the cubic part terms. There's a cube and there's a cube and there's a quadratic. But because I've got a lot of negatives, I just take the negative sign out. So that's going to be negative 2x squared. That's going to be positive x. And that is negative 6 plus 27, which gives me positive 21. But because I took the negative out, it becomes negative 21. Okay. Now the only thing I need to do now is to get the factors. So I get the factors of the cubic, and I'm going to take the factors of the quadratic, right? Let's just check. There's a negative, there's a positive. And there I've got x minus 3, so that will be 2x. And you can see there's negative 6, and that is 7. So that gives me the plus x there. And again, we notice there's a x minus 3 and an x minus 3, right? So if I take that out, I can take out x minus 3 as a common factor. I end up with x cubed plus 3x plus 9. And now I've got minus times 2x is negative 2x. Negative times positive is a negative 7. And if I now simplify that, that gives me x squared. 3x minus 2 is x. 9 minus 7 is 2. And there I've got it there. Okay. Let's check the value of the discriminant. The a is 1, the b is 1, and the b is 1, the a is 1, and the c is 2. If I substitute that in there, I get negative 7, which again indicates I would get non-real roots there. Right? So this will be the rational part, and this part here would be the non-real part. Let's check the value. 1 minus 2 minus 1 plus 6 minus 6, that gives me minus 8. And then if I simplify, calculate that, that's 1 minus 3, 1 plus 1 plus 2, that also gives me a negative 8. So there I factorize it with some exactly the same. So it doesn't matter whether you have negatives or positives, you can do it exactly the same, right? So if I have a negative constant in my factor, I will first do the difference of cube, but then I have to balance it out by adding. Well, let's consider an example here where I've got the a value greater than 1. 2x cubed minus 7x squared minus x, and I even have a constant negative 12. And here I've got a factor with a negative constant of negative 4. Okay. Let's take my expression, that's 2x cubed minus 7x squared minus x plus 12 to the minus 12. So the first thing I have to do is I have to move it away. So I get negative 7x squared, subtract x, subtract 12. Now because I've got negative 4, I have to subtract negative 4 cubed. But because I've got a 2, I'll subtract negative 2 times 4 cubed. So there's negative 2 times 4 cubed. And I now have to balance it out. So I add to that 2 times 4 cubed. Okay. Now just to get the cube part right, I've got a 2 and a 2. So let's rather take the 2 out as a common factor. So I get a 2 with a difference of 2 cubes. And there's a lot of negatives, so take the negative out. So that's 7x squared, that becomes a plus x. And you can see negative 12 plus 2 times 4, 4 to the third is 64. 64 times 2 is 128. Subtract 12 gives me positive 116. But because I take the negative out, it becomes negative 116. Don't worry about the large number. We'll see how simple it becomes. So now I take my factors. So if I have to factorize the cube, it becomes x minus 4. That negative here becomes a positive, and 4 times 16 is my 64. Now, the cubic one, the quadratic one is quite simple. Because you have an x there, x goes into 7x squared, 7x. Negative 4 divided into negative 116 is just 29. There's the factor 7x plus 29. Now you notice there's a x minus 4 which is common. So I take out the x minus 4. Now I still have the 2 left. So it's 2 times x squared, and 2 times 4x is 8, and 2 times 16 is 32. And I've got a negative there, so it becomes negative 7x with negative 29. If I just collect all the like terms, 8 subtract the 7x becomes a x, and the 32 subtract the 29 becomes a 3. Okay. We can also check the value of the discriminant. You can see the a value is 2, the b value is 1, and the c value is 3. If I substitute it into my discriminant there, I get negative 23. So that means I would get non-real roots if I had a equation there, right? So the factors would be non-real. Then let's just check the value here. I have 2 subtract 7 subtract 1 subtract 12, which is negative 18. If I take my factors, that's 1 minus 4, 2 plus 1 plus 3, that also gives me negative 18. Let's take another example. Here you can see the leading coefficient there is not a 1, it's a 3, right? So let's take the example, that's 3x cubed plus 5x squared plus x plus 6. First of all, I just displace it. so I can add my cubic part there. Because I have a 3 and that's a 2, so I'm going to add 3 times 2 cubed. And to balance the 3 times 2 cubed, I'll have to subtract 3 times 2 cubed, which is negative 3 times 8, which is negative 24. Now let's look at the cubic part here. Just take, there's a 3 and a 3, I take out the common factor. There's pluses, so I can just get 5x squared plus x, and 6 subtract 24 gives me negative 18. Okay, now let's factorize the cubic part. I factorize the cubic part there. I get x plus 2, and because there's a positive, that will be negative. And if I factorize the quadratic, which should be very easy, if you've got x plus 2, x into 5x squared gives me 5x, and 2 times what gives me negative 18, 2 times negative 9. Right? It's very easy to factorize that trinomial. I now notice I've got a common factor of x plus 2. So I take out the common factor, x plus 2. But remember, there's a 3 here. So this 3 must be multiplied with that quadratic, 3x squared minus 6x plus 12. And then I'm left here still with a 5x minus 9, because I take out the x plus 2. And now I just need to collect the like terms. Negative 6x plus 5 is negative x. 12 subtract 9 is going to be 3. Let's work out the delta, the discriminant. The a value is 3, the b value is negative 1, and the c value is 3. I substitute, I get negative 5, so again I get non-real factors there. Then let's check the value. I've got 3 plus 5 plus 1 plus 6, which gives me a 15. Let's look at my factors. I've got 1 plus 2, which is 3. 3 minus 3 plus 3 gives me a total of 15. So this one has also worked. Now I'm going to show you how we can do this in 3 steps. Right? We've seen we need a cubic part. There's the cubic part x cubed, and I add the 3 cubed. So I add the 3 cubed, and the quadratic part is my 2x squared minus x. But the plus 6 with the minus 27 gives me minus 21. So I change the plus 6 to a negative 21. Now it's going to be very easy. Okay, I know x plus 3 will have to be a factor. It's a factor of the cubic. So let's get the remaining part of this cubic here, which is x squared minus 3x plus 9. And now I need to get the remaining part of the quadratic. If I've got an x there, the other one, it will be 2x. If I've got a 3 there, the other factor for the quadratic is negative 7. And now I can write down my answer. X plus 3, and you can see there's x squared minus 3x, and 2x gives me minus x, and 9 and minus 7 is a 2. Okay, and I can check it works. 1 plus 2 minus 1 plus 6 gives me a 8. And 1 plus 3 is 4. And 1 minus 1 plus 2 is 2. 2 times 4 is 8. Right? We can even do it in 3 steps. Can you now factorize a cubic if one linear factor is given? I hope this method helped you. It's 4 cubic expressions for you to factorize with a given factor. You may pause the video, then you try it, and then on the next slide here you can see I've got the solutions. They are the solutions. I haven't included the steps because you can do this all with one step. It doesn't matter which of the two methods you want to use. You decide which is the best method that suits you. I also recommend that you watch my YouTube video that I prepared on how to find one rational factor for a cubic, ax cubed plus bx squared plus cx plus d. I prepared a special video on that. If you've enjoyed this video and then you found it useful, I also recommend for you to view other videos on mathematics topics that I've prepared. I've prepared a few other topics also on other concepts regarding factorization of cubic expressions and many other videos on mathematics topics. Please, if you have not subscribed to my channel, Maths with Armin, please do so. Thank you very much.